Okay, so this video is focusing on adding and subtracting rational expressions. And when you add and subtract rationals, you have to think about normal fractions. So when we add and subtract rationals, we have to have a common denominator. So here I have 4 over 3x plus 5 over 3x. I have a common denominator. My common denominator is 3x. So when I add and subtract just basic fractions, my denominator will stay the same. So it's going to be 3x. And then my numerator, I just add straight across. So 4 plus 5 is 9. So I get 9 over 3x. Because it's 3x, that means they're being multiplied. So I can actually simplify even further. So 9 and 3 are both divisible by 3. So I'd make it 3 and 1. So we end up with 3 over x. Next up, I have x plus 5 over x squared minus 3 plus 3x minus 1 over x squared minus 3. I have a common denominator. That common denominator is x squared minus 3. So the numerator now, all I have to do is I need to factor. So, not factor, I'm sorry. I'm going to be combining like terms. Went to a different world right there. So I'm going to combine like terms. So 6x plus 3x is 9x. And then 5 plus negative 1 is 4, so 9x plus 4. And then I look to see, can I factor any further? 9x plus 4 doesn't factor, and x squared minus 3 doesn't factor, so I end up with 9x plus 4 over x squared minus 3. Okay, next up I've got 3x squared minus 5 over 3x minus 1 minus 2x squared minus 3x minus 2 over 3x minus 1. Okay, for subtraction, make sure that the negative is distributed out. I already have a common denominator, so that's good. So my denominator is 3x minus 1. My numerator I can rewrite as 3x squared minus 5 minus 2x squared plus 3x plus 2. And now I just combine like terms. So 3x squared plus negative 2x squared is 1x squared. Then I've got plus 3x and then minus 3 all over 3x minus 1. And then just look and see, can you factor any further? So the numerator, I would need factors of negative 3 that add up to positive 3, which doesn't exist. So I end up with x squared plus 3x minus 3 over 3x minus 1. Now, you don't always get common denominators right off the bat. So here I have x over x plus 3 plus 2x plus 6 over x squared plus 6x plus 9. So I don't have a common denominator from the beginning, which means I'm going to factor everything first. So my numerator of my first fraction is x over x plus 3. So none of that needs to factor. Plus, I've got 2x plus 6, so I can factor out a 2, and I'm left with x plus 3. Over x squared plus 6x plus 9 factors to be x plus 3, x plus 3. And now I'm going to look and see, can I simplify anything? I've got an x plus 3 in the top and the bottom of my second rational. So now I have x over x plus 3 plus 2 over x plus 3. I have a common denominator now, so now I just need to add going straight across. So I get x plus 2 over x plus 3. And that's all I can do here. I cannot simplify out the x's because it's x plus 2, x plus 3, those have to stay together. So that is as simplified as I can get. Now, if it was 2x over 3x, that's all multiplication and division. So yes, I could simplify. But when there's addition happening between two terms, I cannot split them up. Addition or subtraction. Next up, I have 3 minus 4x over x squared plus 3x minus 10 minus 2 over x plus 5. So I don't have common denominators, so I'm going to factor first. So 3 minus 4x, I can't do anything to. Over x squared plus 3x minus 10 factors to be x plus 5, x minus 2. And then I've got minus 2 over x plus 5. So now I look and see, can I simplify any factors? And I can't, which means now I need to look and see what do I need to do to be able to get common denominators. And you always make it bigger. You can't make them smaller. You can't divide by anything or subtract anything. But you can get a common denominator by multiplying. So here, this denominator, they both have x plus 5. But this one has an x minus 2 and the other one doesn't. So what I can do is I can multiply my second rational, top and bottom, by x minus 2. So this is 3 minus 4x over x plus 5, x minus 2, minus, I'm going to distribute the 2, so 2x minus 4 over x plus 5, x minus 2. And now I can distribute out my negative. So this is 3 minus 4x minus 2x plus 4 over x plus 5, x minus 2. And combine like terms. So I get negative 6x plus 7 over x plus 5, x minus 2. Okay, so I multiplied to be able to get common denominators and then combine by like terms. I've got negative 4x squared plus 2 over x squared plus 9x minus 10 plus 3 over x plus 10. So I'm going to factor my numerator. I could technically factor out a negative 2 and make it 2x squared minus 1. I don't think that's going to do me any good though. So I'm going to leave it the way it is. So I've got negative 4x squared plus 2 over x squared plus 9x minus 10 factors to be x plus 10, x minus 1, plus 3 over x plus 10. So I can't simplify out any of my factors or anything, so I'm going to have to multiply to be able to get a common denominator. They both have x plus 10. This one has an x minus 1, so this one needs an x minus 1 now. So I get negative 4x squared plus 2 over x plus 10, x minus 1, plus 3x minus 3 over x plus 10, x minus 1. And now I can combine like terms, so I get negative 4x squared plus 3x minus 1 over x plus 10, x minus 1. Okay, I've got 5x plus 1 over x squared minus 2x minus 3 minus 5x minus 3 over x squared minus x minus 6. So let's factor. So 5x plus 1 doesn't do anything over x squared minus 2x minus 3 factors to be x minus 3, x plus 1 minus 5x minus 3 over x squared minus x minus 6 factors to be x minus 3, x plus 2. I can't simplify out any of my factors, so let's get a common denominator. So they both have an x minus 3 in common, but this one has an x plus 1 and the second one doesn't. So I'm going to multiply top and bottom by x plus 1. My second rational has an x plus 2 that my first one doesn't. So I'm going to multiply top and bottom by x plus 2. So now my next step is I need to FOIL my numerators together, or my numerator together. So here I've got 5x plus 1 times x plus 2. So 5x times x is 5x squared. 5x times 2 is 10x. 1 times x is 1x, and then 1 times 2 is 2. So my first numerator is 5x squared plus 11x plus 2 over x minus 3, x plus 1, x plus 2, minus my second numerator, I've got 5x minus 3 times x plus 1, so 5x times x is 5x squared. 5x times 1 is 5x. Negative 3 times x is negative 3x, and negative 3 times 1 is negative 3. So my second numerator is 5x squared plus 2x minus 3 over x minus 3, x plus 2, x minus 1. Now I need to distribute my negative to my second numerator. So 5x squared plus 11x plus 2 minus 5x squared minus 2x plus 3, which means my numerator is going to be 9x plus 5 over x minus 3, x plus 2, x minus 1. So all I did here was I combined my like terms to get my new numerator, and then my denominator were all 3 factors. And last example that looks really, really difficult, but it's not that bad. I've got x over 4 plus 3 over 2 over 2 minus 3 over x. Take it one step at a time. So first deal with x over 4 plus 3 over 2. So to add those together, I have to get a common denominator. I've got a denominator of 4 and a denominator of 2, so a good common denominator is 4. So I'm going to make 3 over 2 turn into 6 over 4. So this is x plus 6 over 4. Okay, my bottom half, 2 minus 3 over x. Think of this as 2 over 1, so I need to get a common denominator. So a good common denominator is x. So I'm going to multiply 2 over 1 top and bottom by x. So this is 2x minus 3 over x. What this equation is saying is x plus 6 over 4 divided by 2x minus 3 over x, which when we divide fractions, we really multiply by the second fraction's reciprocal. So this is really x plus 6 over 4 times x over 2x minus 3. And now when you multiply fractions, you just multiply straight across. So then this ends up being x squared plus 6x over 8x minus 12. And that is it for adding and subtracting rational expressions.